One can also use the electrochemical series to predict whether a given metal will displace another from its salt solution. So what do I mean by this? So let's consider two scenarios um, where I have dipped an copper rod, a copper rod in zinc sulfate, so zinc sulfate solution. So it's a zinc sulfate solution. In another case, I have taken zinc rod in a copper sulfate solution. So what I'm asking is, does copper from the electrode come out as Cu2 plus and then combine with SO4 2 minus from zinc sulfate and then form copper sulfate, or does zinc come out of the electrode as zinc 2 plus and will they combine with sulfate from copper sulfate and then form zinc sulfate? Now let's look at the values of the reduction potentials of zinc and copper. So if you go to the table that I have just given at the top, you will see that zinc has a standard electrode reduction potential of minus 0.7628, whereas copper has a standard reduction potential of plus 0.337. And I just mentioned in the previous video that any metal which has a negative reduction potential is highly electropositive. That means it has greater tendency to form cations. So if we go by this reason, we can say that this reaction will not happen, but rather it's this reaction which is feasible. So zinc zinc can zinc can displace, so we can say that zinc will displace copper from copper sulfate solution, but copper cannot displace zinc from zinc sulfate because zinc has a greater tendency to lose electrons than copper. So it's than copper. Thus, one can say that metals which are higher in the electrochemical series can displace the metal from metal which are lower in the series from its salt solution. from its salt solution. So in other words, I can say that a metal having a low standard reduction potential will displace the metal from its salt solution, which has higher value of standard reduction potential. So that's the big takeaway from this. The third application of the electrochemical series is one can predict whether a given metal will displace hydrogen from dilute acids. So we can say, we can predict to predict if to predict if a metal can liberate H2 or hydrogen from dilute acids. So let's try to understand this. So based on the statement, any metal thus any metal which is placed above hydrogen in the electrochemical series will readily liberate hydrogen whereas those metals which are placed below will not. So let's take, so we just saw that zinc has a standard reduction potential. So zinc has a standard reduction potential of minus 0.73 or something, and we know that hydrogen standard reduction potential is 0. So we say that if zinc is kept, or let's say for zinc metal is kept in a dilute acid solution, then you will have hydrogen getting liberated. So what does this mean? Now to understand this, let's construct a cell. Let's say for example you have zinc and zinc 2 plus, and you have She. Okay, so I'm not representing in the correct way the cell that is formed by combining zinc and She. In another case, you can also draw it the reverse way. So you can also draw it the reverse way. So it's She and zinc 2 plus zinc. Now here zinc acts as the anode where oxidation occurs. Okay, so where oxidation occurs, whereas in this case the She acts as the anode where oxidation would occur. Now let's calculate the E cell. Let's calculate the E cell of both these cases. So the value of this is roughly 0.763. So let's calculate the EMF of the cell which I have denoted on the left, and the cell which is constituted by She acting as the anode on the right. Now in this case, the E of cell, so the E naught of cell is given by E naught of She minus E naught of zinc electrode. Whereas in this case, E naught of cell is given by E naught of zinc electrode minus E naught of She. So if we calculate here, so this will be 0 minus of minus 0.763, so which becomes plus 0.763. Whereas in this case, E of cell will be equal to minus 0.763 minus of 0. So this will be minus 0.763. So from this we can say that since the E cell is positive in this case, so the E cell is positive in this case, we say that this reaction is feasible. So if you write this reaction, so you will see that so zinc is actually oxidizing. So let's say it's an zinc hydrochloric acid. So zinc will get oxidized. That means zinc will form zinc sulfate and hydrogen will be liberated. So that's the another application of the electrochemical series.